about Z11. What was the answer? S square
plus S plus 1
upon
S square plus
Is it right now? So Z11S happens to be S square plus S plus 1 upon S square plus 1. So it has got three zeros. Z1, Z2, Z2. What those are?
minus 1 plus
Those are Z1 is
minus 1 by 2 plus
minus half plus
root 3 by 2
3 by 2Z. Z2 is again minus half minus root 3 by 2Z. What is Z3?
क्वाड्रेटिक है सर क्वाड्रेटिक इक्वेशन है सर क्वाड्रेटिक है जेड तो सर क्वाड्रेटिक है जेड की कैसे थे
Yes, right? So now we shall try to analyze this equation in detail. So S minus Z1 into S minus Z2. So there are two zeros and two poles are at P1 equal to Z and P2 equal to minus Z. It has got two poles. Is it clear? So zeros and poles are those values of S for which the network function either becomes 0 in case of zeros or becomes infinite in case of poles. Writing values here is a very simple task which has been done. Now the question is interpreting these values. Zeros of the function. I again repeat, zero of a function means if we apply an input, all these things are with an assumption that the input applied is of the type e raised to st. E raised to st is a two-dimensional quantity. S is a complex variable which may contain real and imaginary parts. So if S is positive, in that case e raised to st, how it grows? E raised to st grows in this manner as t proceeds. E raised to st. The big question is, what is e raised to st? E raised to st is a point in 2D plane. E raised to st is a point in 2D plane. Then obviously this itself cannot be applied. This itself cannot be applied. Why? Because voltage is one-dimensional. Then what do we do? Instead of applying e raised to st alone, we apply e raised to st plus e raised to s star t. or S can has a particular value, so I will say I may apply S equal to S1 e raised to S1 t plus e raised to S1 star t. What is S1 star? Complex conjugate of S1. So e raised to S1 t will be a point which will e raised to S1 t, what it is? It is a point in 2D plane which is either growing or contracting towards 0 and rotating either clockwise or anti-clockwise. I again repeat. For example, if S1 is one plus z, what will happen? It would be e raised to 1 plus zt, means what? E raised to t into e raised to zt. What is e raised to zt? It is cos t plus j sin t, means it is a point on the unit circle moving anti-clockwise with an angular speed of omega equal to 1. It covers an angular distance of 1 radian per unit time. So when I have this S1, e raised to S1 t will become e raised to 1 plus zt, that is equal to e raised to t into e raised to zt. What is e raised to zt? E raised to zt is a point which is moving on this circle in this manner with angular speed of 1. Now what is e raised to t? E raised to t is equal to 1 at t equal to 0 and growing exponentially. Right? And then e raised to t into e raised to zt will be what? Will be a point which is at unit circle initially and growing in this manner. I hope you understood it. Then e raised to S1 star t is what? S1 star is nothing but 1 minus z. So it will be e raised to t into e raised to minus zt. What would be e raised to minus zt? It is a point moving clockwise. Therefore, when I add up e raised to S1 t and e raised to S1 star t, what I get? When I add up e raised to S1 t and e raised to S1 star t, what I get? What do I get? I get e raised to t 2 cos t or 2 e raised to t cos t. What 2 e raised to t cos t? Cos t? 2 e raised to t cos t is an oscillatory waveform but whose amplitude is growing exponentially, and it is like this. Then that is one dimensional and that can be applied. That can be applied. E raised to st is 2 dimensional. E raised to s star t is also 2 dimensional. None of them can be applied, but their addition can be applied. So I can say when I apply 2 e raised to t cos t, which can be actual signal which can be generated by some technique, I can say that I have applied e raised to s1 t plus e raised to s1 star t where s1 is 1 plus z. Are you getting me? So I can consider one dimensional signal as a combination of two dimensional signals. So applying two-dimensional signal remains a hypothetical thing, but I can analyze everything considering that as if that has been applied. I can analyze everything considering that everything has been applied, I can come up to the result. I can then apply e raised to s1 star t. I can come up to the result and I can add the results by superposition theorem. And that simplifies my task. The handling of e raised to st is very easy situation to handle because the integral and derivative operators have become scaling operators, and therefore only I can replace the impedances by S and 1 upon S, which I could not have otherwise done. No doubt that you can do it using only sinusoidal, but that is somewhat limited sense meaning. E raised to st is having wider sense meaning. I will not claim that each and every individual has to understand all these things at this juncture, because it's a very complex and deep theme which would be understood by an individual depending upon his interest to understand, his capability and his sincerity. And obviously it is a longer time process, and I hope that everybody will understand it at one or other point of time. So then zeros, so ultimately every network function is a function of S, a ratio of polynomials of S, that is numerator Ps and denominator Qs. Then it will have some zeros, means a typical value of S for which the operations inside that circuit are such that we get zero output, or a pole, means the value of S for which the function becomes infinite. Then this particular circuit is having zeros at 2 points, and we will observe that it will be complex conjugates, zeros as well as poles. Both are complex conjugates. So 0 is at minus half, that is 1 0, and other 0. 1 0 and other 0. These are two zeros. And one pole and other 0. So if S is a, what we can say, parameter. What is difference between parameter and variable? We give a very crude difference just to it is not a classical, it should not be quoted. Just for those who might have unnecessary confusion, parameter is something which is between constant and variable. It's very crude. I am not claiming it to be scientific definition. It is not to be written anywhere, but for our own understanding, parameter is something which is between constant and variable. Constant is always constant, variable usually continuously varies, and parameter varies at a lower degree, means it is not dead constant. It takes place different values one at a time. So in e raised to st term, t is variable, e is constant, and s is parameter. So you can have s equal to s1, s equal to s2. For different values you can compute e raised to st. So zeros of the function are such that if S takes that value, then for that particular e raised to st, the current would be 0. And in this case, the value is Z1 equal to this and Z2 equal to this. Means, if what is its interpretation? If I apply a signal e raised to minus half plus root 3 by 2j t, or e raised to minus half minus root 3 by 2j t, if either this or this, then I can say I can apply this plus this also. Both are 0 points. So if I apply this, what this would be equal to? This would be equal to e raised to minus half t into cosine of root 3 by 2t into 2. So it would be a particular decaying cosine signal. It would be a particular decaying cosine signal. If that is applied, then what will happen? You would be finding that there will not be any current. If this signal is applied, if you apply this here, there will not be any current. How can you prove this? How can you prove this? Means we apply something here as e raised to sigma t cos omega t. That's all. Find out omega. E raised to sigma t and cos omega t. When we apply, we should get 0 current. You can find out sigma and omega also, and you will find that those come to this. We can have it try. So I would like to see that you get a fair idea about what zeros and poles mean. So about everything. Is immaterial. This is constant. That constant is immaterial. That find out sigma and omega such that now in this you are not supposed to use this s and all that. Now s is gone. S is gone. We need to use differential. We need to use differential because st what we try to get this one dimension. This can be applied. This one dimension, this can be applied. So how will you find out? So when this current is 0, means this voltage must be also same as this. This voltage also must be same as this. Are you agreeing now? So we want that when we connect a signal e raised to sigma t cos omega t, we want sigma and omega which give rise to 0 current. Giving rise to 0 current means this voltage must also be same. So this voltage is e raised to sigma t cos omega t. When we apply that, what will be the current to this? No, why 0? We applied this, so it's derivative. We will current here. But what we want? We want total current to be equal to 0. So if some current flows in this direction, what must happen? A reverse current must flow through this direction. right? And what is this voltage then? Its derivative, because L di by dt is 1, and that must be same. So we can find it very easily. So now find ICT. What is ICT? E raised to sigma t first in derivative of second sin omega t and minus omega, right? First in derivative of second plus second to derivative of first plus sigma e raised to sigma t correct? Is it agreeable? What is this? This is ICT. This is ICT. So what is ILT? What is ILT? Negative of this. Why? Because total current must be 0. So ILT is plus omega e raised to sigma t sin omega t minus sigma e raised to sigma t cos omega t. This is ILT. Means we assume ILT is this only. ICT is this only, right? So ICT and this is minus of this. What is VLT? What is VLT? What is L? 1. So its derivative. What is that then? Its derivative. What is its derivative? And this must be equal to this. Because VLT is same. So find out its derivative and that must be equal to this. So what is its derivative now? I will find omega into bracket rid of this e raised to sigma t omega cos omega t plus sigma e raised to sigma t sin omega t. Here minus sigma into bracket minus sigma into bracket this entirely, that is minus omega e raised to sigma t sin omega t plus sigma e raised to sigma t cos omega t. Now you may match. So you collect the terms of and you will get, so you get something cos t plus something sin t, that must be equal to, means you get e raised to sigma t outside completely and you get something cos t plus something sin t, that must be equal to, you get something cos omega t plus something sin omega t, that must be equal to cos omega t, and for that you can get both values. For that, by solving the equation you will be getting the values, and those must be minus half, those must be minus half and root 3 by 2. Sigma you get as minus half and omega you get as root 3 by 2. You got their values? So for that whether what the experience is last time it was the final answer. No, no. So for these values of S, we get the current as 0. For these values of S, we get the current as 0. And now an interesting phenomenon which we must look into. Z11S is equal to S square plus S plus 1 upon S square plus 1, which corresponds to, forget about numerator as it is, and in the denominator I have got S minus Z and S minus Z. Right? So the poles are plus minus Z. Poles are plus minus Z. So if I apply, now it's quite an interesting thing, if I apply e raised to zt or e raised to minus zt, if I apply e raised to zt or e raised to minus zt, what will happen? For these means for value of S equal to plus Z or minus Z, what is happening now? The circuit is leading to infinite current. Circuit is leading to infinite current. So if I apply this e raised to zt plus e raised to minus zt, means what I am applying? Means what I am applying? Means I am applying 2 cos t. I am applying 2 cos t, right? So if I apply 2 cos t, what happens? If I apply 2 cos t, analyze the circuit. If I apply 2 cos t, what will happen? So try to analyze the circuit. Now forgetting everything, using your differential by all possible ways what you can, try to analyze the circuit for this now. 2 cos t, when you apply, what will happen? What will be the current? is immaterial. So if you don't want to use 2, you can rub out 2, right? So 2 is not important. Only you can say cos t, right? 2 is not important. So cos t is applied here. What will be the current? If you found out Vt equal to cos t, what will be the current It? What will be the current It? How we will proceed further? We had developed one very preliminary brute force method, that in a circuit where we are having one sinusoid, every voltage and current will be or can be expressed as A cos t plus B sin t. Every voltage or current can be expressed as A cos t plus B sin t. So what is to be found out? It is to be found out. So I can very well say It is equal to A cos t plus B sin t. Is it alright? In any circuit, when I have one sinusoid, a sinusoid voltage is applied, then voltage at every point or current through any branch will be always A cos t plus B sin t with different values of A and B. This is It. Then what is this voltage? I can say V1t. What is V1t? What is V1t? This minus It into R is 1, so V1t is equal to 1 minus A cos t minus B sin t, correct? Is there any problem? I think not. Is it alright? Is it okay? Now, to find out these values, how will you find out? What is ICT? ICT would be C is 1, so its derivative. What is that then? That is equal to ICT is equal to, means the entire thrust is to avoid integration. Entire thrust is to avoid integration. So ICT is derivative. Derivative of cos is minus sin t, right? So A minus 1 sin t, and derivative of sin is cos t. So minus B cos t. What is this? ICT. This is IT. This is ICT. So what is ILT? What is ILT? IT minus ICT. IT minus ICT. So what it is? ILT. What is ILT? IT minus ICT. So it is cos terms you can have A minus B. Sorry, ILT is IT minus ICT, means A plus B cos t, and as regards to this, cosine B minus A plus 1, that is plus 1 minus A plus B sin t. This is what? ILT. Now what is VLT? LDI by dt. So you find it out from this. From this now you find out VLT. What it is? Minus A plus B sin t. So I will write reverse. This is to cos t. That is 1 minus A plus B cos t and plus minus A minus B sin t is VLT. But what is VLT? It must be V1t. So V1t is this 1 minus A and this I write plus minus B. So match the coefficients. So write equations now. 1 minus A is equal to 1 minus A plus B and minus B equal to minus A minus B. Is it right? So find out values of A and B. Find out values of A and B. What those are?
0, 0, 0.
Could you get the values?
0 and 0.
B equal to 0. A equal to
Current at 0.
so what happened?
Current 0.
What is IT then?
What?
Is it 0? IT is 0? V1t is cos t. This is minus sin t. This is plus sin t. So where we ended now? We started with the values of s which were supposed to be poles of the function. And where we did end? Right. So S resulted to be now infinite. Z11S resulted to be, our previous statement was somewhat wrong, I will correct that. So as regards to zeros actually when impedance is 0, it should have been infinite current. So the previous part we discard and now we come on this part. So the discussion which we had for zeros is to be completely discarded, and you refer this now. So we have started for the values of S for which we will be getting pole of the function, means value of Z11. What is Z11? Ratio of, it is a driving point impedance, ratio of voltage upon current, and for Vt equal to cos t we find that no current flows, so it's a pole of the function. So what pole of the driving point impedance means an infinite impedance. Pole of the driving point impedance means an infinite impedance, means zero current. Now, zero of the impedance function. What does it mean? It is virtually a short circuit. Zero of the impedance function is virtually a short circuit. What we may try to analyze in reverse way. Zero of impedance function is pole of admittance function. Zero of impedance function is pole of, means if I write Y11S, it would be S square plus 1 upon S square plus S plus 1. In that situation, if I apply a constant current source, as input, means instead of applying voltage source, if I apply a current source here, IT equal to what we had discussed, that is e raised to sigma t cos omega t. IT as e raised to sigma t cos omega t. If we apply this, in that case there we will be getting one particular value of sigma and omega. We will be getting one particular value of sigma and omega for which this voltage would be 0. Applying voltage source and getting current to be infinite is difficult to derive. So apply a current source IT equal to e raised to sigma t cos omega t, then there will be some voltage, this plus this, and it will be such that their addition would be 0. This current, here there will be some voltage. For that voltage you compute the currents and find out value of sigma and omega, for which, for this current, this voltage plus this voltage will become 0. These are the poles of admittance function or zeros of impedance function. This is for driving point functions. For transfer functions, the same theory will hold good, and looking of the denominator for transfer functions is very much critical as regards to stability of the network. As stated at the beginning itself, this is not a simple theme. So it requires your interest, capability and sincerity to understand them in detail. So I hope that all these three will grow with respect to time and you will be able to understand them very shortly. Today we will not be engaging extra lecture, we will be engaging tomorrow's lecture, that is at 12:15 and 1:30. At 12:02. Thank you.